Okay, in 5.3 we're going to do double angle and half angle formulas. So if you look right here, you have the given formula and also the half angle formulas here, which are a little bit blurry, but you can print them out on your handouts. So the first one is that we're given information and we want to find the exact value. So the first one we're going to look at is the sine of 2 theta. Okay, we'll look back to our formula sheet to find the sine of 2 theta. Using the formula, it is right here. We're going to write it on the next page. Okay, so let's evaluate. First of all, let's go off to the side. They give us cosine of theta equals 4/5 and tell us that it is in quadrant 4. So let me come over here and quadrant 4, cosine is going to be, what's your cosine? Your x value over your r, remember, so cosine is 4, the r is 5. So how do we find out this missing side? Yeah, we can use Pythagorean theorem or any other thing. So what would we get here if we had, right, so this is the hypotenuse side is 5. Also this would be 4, so we will find out that this is 3, but if it's going down, what do we need to imply because it's in quadrant 4? What is the cosine in quadrant 4? Yeah, so that one's going to be -3. Alright, so now that we have this, we want to be able to use that information to plug in here. What is going to be the sine of theta? Your sine of theta is your y value over your r value, so that's going to be what? Y value over your r value, so that's going to be -3/5. Let's drop this 2 down. And now let's evaluate cosine of theta. Well, we already know what cosine of theta is because it was given in the problem. So we'll just put 4/5 there. And then it's a simple multiplication there. You can cross cancel if when possible, but if not, we multiply straight across the top. So that would give us -24 over 25. So this is the sine of 2 theta. Okay, let's do cosine of 2 theta. So let me go back to the previous page. Cosine of 2 theta can have different variations of this particular one. I'm just going to use this first one, cosine squared theta minus sine squared theta. Other times it may be more suitable to use one of these. Just depends on the problem, but we're just going to use this particular one. So cosine, let's write our formula. Cosine of 2 theta is equal to cosine squared theta minus sine squared theta from the previous formula sheet. Okay, well, we've already done our calculations over here. So let's go ahead and put, what is the cosine of theta? It's 4/5, but we're going to square that, so this is going to be 4/5 squared, and we've already calculated what is the sine of theta. We said the sine of theta was -3/5, so let's do -3/5 squared. And then let's actually calculate those. This would give us 16/25. Let me move this out the way. 16/25. And -3 squared over 5 squared is 9/25. So then simplify this even further, and we find out that the cosine of 2 theta is 7/25. Okay, let's calculate the tangent of 2 theta. So let's peek back on the previous page. Tangent is this formula right here, so we want to write it down. Always start with writing our formulas. Tangent of 2 theta is equal to 2 tan theta divided by 1 minus tangent squared theta. Real quick, let's write down tangent of here is going to be your y divided by your x. So our y is -3 and our x is 4. So let's use that value when we plug into this formula. So we're going to have 2 times the tangent theta, which is -3/4, divided by 1 minus -3/4 squared. So that's going to be -3/2. And then let me do 1 minus 9/16, so not to simplify too much all at one time. Okay, so that's going to give me, I'm going to leave the numerator alone and then over squared. Let me rewrite that. So -3/2 divided by 1 minus 9/16, just going to give us 7/16. Okay, multiply by both sides by the reciprocal. 16/7 times 16/7, which simplifies to -24/7. Okay, the next type of problem says write an expression as the sine, cosine, tangent of a double angle, then find the exact value. So first of all, we look at this expression and we identify that it matches which of our formulas. Well, clearly 2 tan theta over 1 minus tangent squared theta, we want to know if our given is in that format, and if so, then it's safe to say 2 tan theta over 1 minus tan squared theta, which is our formula, is equal to tangent of 2 theta. Okay, well, comparing these two, can you tell me what theta is going to be? Theta is pi thirds, right? Yeah. So if that's the case, and we know that this is equal to tan 2 theta, then I can say the tangent, I can evaluate this by saying tangent of 2 times theta, which let me do it in a different color. I plug in theta, simplify that, tan of 2 pi over 3. Okay, so now go to your unit circle. Okay, let me see, I might pull one up. Okay, 2 pi over 3 is up here, so your tangent is your y value over your x value, so that's going to be square root of, well, square root of 3 over 2 divided by the y value, which is -1/2. So basically we want to simplify this, so let's multiply by the reciprocal. -2 over 1 times -2 over 1. Everything on the bottom is going to simplify, and we're going to be left with square root negative square root of 3. So we will use our formulas to get us to this point to evaluate, and then of course we just fall back on to being able to use our unit circle to get an exact value.